Exercise 8.2. Question number 6. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Solution. Given ABCD is a quadrilateral in which P, Q, R and S are the midpoints of the sides AB, BC, CD and DA. Line segments joining the midpoints of the opposite sides of the quadrilateral are PR and SQ. To prove PR and SQ bisect each other. Construction. Join PQ, QR, RS, SP and AC. I join these lines like PQ, QR, RS, SP and AC because I want to prove that PQRS is a parallelogram and PR and SQ are the diagonal of the parallelogram PQRS. And we know that in a parallelogram diagonals bisect each other. Then we will solve the question. So I join PQ, QR, RS and SP and AC. Proof. Here diagonal AC divides the quadrilateral in two parts. That is two triangles. One is ABC and another is ADC. At first I will take a triangle ABC and then I will take the triangle ADC to prove that PQRS is a parallelogram. So at first in triangle ABC. In triangle ABC, P and Q are midpoints of AB and BC. By midpoint theorem, PQ is equal to half of AC and PQ parallel to AC, equation number 1. Now in triangle ADC, S and R are midpoints of AD and CD. By midpoint theorem, SR is equal to half of AC and SR parallel to AC, equation number 2. Now equation 1 and equation 2 are PQ is equal to half of AC and PQ parallel to AC, that is equation number 1 I have already proved, and SR is equal to half of AC and SR parallel to AC, equation number 2 I have already proved. From 1 and 2, PQ is equal to SR and PQ parallel to SR. Since one pair of opposite sides of quadrilateral PQRS is equal and parallel, hence PQRS is a parallelogram. Now PR and SQ are diagonals of parallelogram PQRS. Since diagonals of a parallelogram bisect each other, here PQRS is a parallelogram and PR and SQ are diagonals of parallelogram PQRS. Hence, PR and SQ bisect each other. Proved. Thank you.